Alliance for the Environment, or SAFE, is going to be the virtues of green building. And I want to welcome all of the attendees here. I know we've got kind of a great mix of folks that often are on our SAFE calls on a monthly basis. We typically have these the first Thursday of every month. We've got a good showing of folks from Waring, which is the building that we're going to be talking a little bit about this evening, as well as folks from the Rocky Mountain Institute Building Electrification Accelerator that many of us on SAFE have been part of for the last several months as well. So I think we've got folks from all different areas that are joining us. So I really welcome everybody. As Pat said, if you join, if you can introduce yourself in the chat function, that just helps us know kind of who's here or where you're from. And we'll make sure that we kind of, keep you posted on what we're doing. We do ask that folks stay muted during the presentation and that the questions go in the chat, and we'll try to make sure we get to those. But what we'll do tonight is basically have a small presentation and then a panel of us answering questions. So at that point, we'll go through the questions in the chat, but we may ask you to unmute at that point and ask your question directly if we can manage it that way. So with that, we are going to be recording this. So I wanted to let everybody know that, and then we'll move forward, hopefully. So again, welcome to the next SAFE meeting here, our monthly meeting on March 4th, 2021, the virtues of green building. And tonight we're going to be talking about those virtues kind of through the lens, if you will, of the Waring Passive House School building that we've been building for the last year and a half or so. It's coming right along. So our general agenda here is that we'll talk for a little while about why buildings are an important part of the climate puzzle, what the different types of green building options are, and Tim Block's going to lead us through some of that, and then he's going to kind of launch right into the Waring House Passive House panel here, and then we'll answer questions. So I will introduce our speakers. So my name is Cindy Keegan. I'm the co-chair of SAFE and the chair of the Building and Grounds Committee over at the Waring School. We've got Tim Block here with us this evening. He's the management partner and the architect from Opal Architects that worked on this project and developed it for us. Nat Coughlin is the president of LD Russo, and he's our contractor on site. Craig Douglas is our owner's rep for Waring, as well as an architect and a parent of Waring students. And then my son's gonna hopefully join on as well, Colin Keegan, just to kind of give you a perspective from the student perspective. So with that, what I'd like to do is just turn it over to Tim Block, and he can go ahead and present. I do want to recognize here too that we do have Tim Backlund on our call here this evening, and he's the head of the school at Waring. We have several other folks here as well, and then we also have Paul Tucker, our state rep, so I want to recognize him as well. And with that, Tim, hopefully you can share your screen.
Yeah, I will do that. Thanks everyone for joining. Excited to be here tonight with everybody. And I will make sure this works first and we'll go from there. Okay, can everybody see my screen?
We can.
Does it say the ecological imperative on everybody's screen?
Yep.
All right, excellent. Hold on just a second. So we got involved with this project in early 2019. So it's about 2 years, our journey with Waring on this project. And for us, when we approach green buildings, we founded our firm with a understanding that there was an ecological imperative for architects and builders to recognize in our relationship and humans' relationship with climate and with ecology. Our firm's mission is essentially that everything that we do as architects and as builders in our engagement with the built world is ostensibly ecological, that these buildings are manipulations of the environment and therefore have an ethical imperative to hopefully contribute positively to it. And what that means, of course, is that really our decisions around buildings are about our relationship to resources. Buildings are built of materials and then use energy that's derived from materials that are ultimately extracted from the earth. And therefore, we have a pretty significant impact. And we have one Earth of resources, of course, yet on average across the globe, we use 1.7 Earth's worth of resources at our current rate. And in the US in particular, we use 4 Earth's worth of resources prorated for our country and our population. So it's an issue, right? And we need to kind of recognize that as society and then as architects and builders as we go forward with our work, because we contribute to that and that can be positive or that can be negative. And I really love this quote that the ultimate hidden truth of the world is that it is something that we make and could just as easily be made differently. And so when we started our practice, we kind of asked ourselves that question: how could we do this differently that would be positive and not negative? I think that there's an inherent, I don't know, maybe zeitgeist that buildings are automatically a draw on the environment, that they're going to be a negative impact, and it's about reducing that negative impact. But we're starting to think about that in an opposite way. Like, how could we make this different? And it's a great opportunity because buildings represent in their operation and construction, and all the materials that are extracted from the earth that go into that construction represent almost 40% of global carbon emissions across all sectors. And of that, 80% is building operations alone. So the energy we use in keeping buildings running, over the course of their lifespan, and they last a long time, right? 50 to 100 years, these things are standing up and using energy, using materials and in maintenance, et cetera. So if you look at that, and then you look at the amount of new construction that's being created every year, we look out to 2060, so 40 years into the future, and 2.5 trillion square feet of new construction will be built. And that's the equivalent of building New York every month for the next 40 years. Well, we better make some really good decisions about the buildings we built if that's what's happening, if that's the trajectory we're on. And so for us, we asked ourselves a simple question: what if buildings improve the world? Let's imagine that hypothetical, instead of the gut reaction that they're automatically going to be a draw on the environment. And so in choosing how we related to existing building certifications or green building metrics, we immediately gravitated towards Passive House. And I have kind of like these 4 sections here. There's Passive House. These are kind of the main building certification criteria that are used currently in the US. There's LEED, which is the oldest of the 4 and probably the most well-known. There's the Well Building Standard, which is a European-based standard, but is starting to be adopted here. And then there's Living Building Challenge. And we kind of saw immediately that our general mission and our general approach to practice aligned really specifically to Passive House. And that represents the single biggest reduction out of all 4 in the amount of operational carbon used by buildings. So to us, if we're going to make the biggest possible swing we can at this problem, it was obvious that we had to choose Passive House. So we made the kind of audacious statement that we're going to bring Passive House to every project, whether the client wants to certify a building or not. And luckily, Waring wants to certify a building, which is great. We always like that alignment. But we kind of felt like it was our ethical imperative as architects with this big of responsibility to do that. So what is Passive House? Essentially, it's taking a standard construction building. It's adding a lot of insulation to it, particularly in a northern climate like New England, to make sure that any heated air stays inside the building, any cooled air stays inside the building. Then we want to air seal it. We want to make sure, again, that unconditioned air outside doesn't get in. A really simple concept, but a lot of us might live in drafty houses and you know what it's like to not have that air sealing. But once we do that air sealing, we need to add ventilation so we don't die, because we can't just breathe carbon dioxide as humans. So we want mechanical ventilation. We want to be able to make sure, even in the worst conditions when our windows are closed, that we're getting 100% fresh air from the outside, and that's tempered by the outgoing air coming out of the building. This has been especially important during the last year. All of a sudden, everybody knows about ventilation rates, right? Well, Passive House has been doing 100% outside air since its inception in the mid-90s, and we do that in all of our buildings because we think it's appropriate to this building technology and typology. Then we want to have triple glazed climate specific windows. So both of those things together, triple glazed so that, again, so that that tempered air doesn't get out of the building, and climate specific, so we're letting in as much of the sun's energy that we can and rejecting energy if it's in a climate where we don't need that sun energy. And then again, this is all Passive House is built around this idea that we should use as much of the heat that's passively generated as possible. So that can be body heat from us inside the building, that can be sun heat from the sun. It can be even heat generated by the computers, the refrigerators, the dishwashers, the servers that we use inside our building. All of that's heat. And let's use that instead of the heat that's generated from fossil fuels, electricity, whatever. What does that mean? It means an 80% reduction in energy use across all building types. That's the single most important goal of Passive House, is reducing that energy. And that's applicable to any building type. Doesn't matter size, scale, typology. And that's what's really interesting about Passive House versus other building standards, is that you really only have to hit these 3 criteria. You don't have to submit a bunch of materials to a LEED certifier. You don't have to be part of some much more subjective analysis that Living Building Challenge, for instance, has, but it's really just about minimizing the amount of energy used for space heating, minimizing the amount of air that leaves the building through the walls, so field verified air certificate, air sealing testing, something we've been doing ongoing at the Waring School. And then the total energy used by the building, so not just for heating, but all the computers, all the plugs, everything has to be below a certain number, and we call that EUI. That's energy usage intensity, and it has to be below a threshold. And that is all based on square foot, so you can take this and apply it to any size building, no matter what. And so it's a very simple, but very, very stringent metric that we go by for all of our projects. And again, that gets you to that 80% reduction. And when we took this to Waring, we knew that this was a very key component. It was one of the 5 objectives for the project. But as we started to talk to the community and we did this kind of word cloud early on, it came up as a very important thing. But really, in any architectural project, there's all these other things you have to manage as well. So when you get to scale, what I would call Waring a medium-sized academic building, we have some projects that are larger, but some that are definitely smaller, all around this metric. You just have to start balancing all these different desires with that ultimate Passive House objective. And Waring wanted to be a certified building, not just designed to the standard, but actually get that certificate. If we get it, and we're on track to get it, we're in the clerical phase. We're just submitting photos, making sure we did it the way we said. It will be the first certified Passive House school in Massachusetts as of right now. Hopefully nobody sneaks in under the gate before us, but Cindy and I checked today. As of today, we would still be the first one, which is great. So we're almost there. And that really involves, looking specifically at the floor plans and then and the layouts and everything that we worked with on an architectural level with the faculty, with the staff, with the students, and make sure that it also works in an energy model. We have to energy model this building every phase of the project. And when it's working, when we know it's working, we see this type of chart here, where on the left is all of the heat loss in the building. And on the right here, is how the heat is generated in the building. And in a Passive House, we like to see it result in this kind of 1/3, 1/3, 1/3 breakdown approximately. So 1/3 of the energy is being produced by the sun coming through the windows and heating the space. 1/3 of the energy is being produced by body heat in the space. We give off 250 BTUs an hour, human beings. So we want to use that. And only 1/3 of the energy for heating is produced by the heating system itself. When we know that that's working, we see this breakdown that looks just like that. And it can be a house, can be a school, doesn't matter. And it had to also, of course, meet the criteria for working with the site. And there was a very, very unique situation at Waring where there's an upper campus and a lower campus that were not connected by a building. They were connected by a long exterior stair that flooded all the time and poured water into the old school building. So we wanted this building to not only be Passive House, but be an architectural form that allowed that landscape to be circulated through, and provide universal access from the lower campus to the upper campus. And so adding on these formal challenges sometimes makes a passive house more difficult. But one thing we've said from the beginning in the foundation of our firm is that we feel strongly that any building can be a passive house as long as you take the right approach and still meet the architectural needs. And part of that was, looking at that circulation on the upper floor and making sure that we use that as a heat generation device. So there wasn't optimal exposure to south in this project, and there was also a lot of trees, a lot of existing landscape that wanted to be retained. But by using this L-shaped form on the second floor, we were able to even create this armature to space heat the interior of the upstairs through the circulation space by facing that angle to the south. And again, that offset between sun's energy and the amount of heat loss through the windows becomes evened out and zeroed out. And that's the key with those climate specific windows.
Hey. Turn right.
Hello?
Why are we?
Somebody mute themselves. Nat can talk about how annoyed he is about getting these windows from Germany, but sometimes we need to find the right glass for the right place and make sure that it works so that throughout the lifespan of this building, we know that we can count on that energy return in the building. And so here's a view just of that kind of upstairs that wraps to the south and has this kind of long run of windows that allow that interior circulation space to be heated. And so what does that mean if we were to take the same approach but do a conventional building? So we have the same design, but it doesn't have the insulation, super thick insulation, doesn't have the good windows, doesn't have the air sealing. Well, it wouldn't just be double. This red square wouldn't just be double. It wouldn't be triple. It'd actually be off this graph. So in a conventional building, which I think a lot of us probably on this call know well, you're essentially relying solely on your heating system, and it is dwarfing the amount of heat generated by our bodies by the sun. And we want to avoid that. That's the idea of conserving that operational energy. And the end result, for us is an incredibly successful project, we feel, and it's not quite open yet. We're just a few weeks away, but on track to be certified. We're in the final steps of that, so that's great. As we said, first passive house certified school in Massachusetts, it's looking like, unless somebody sneaks in ahead of us. And an EUI of 15.36. Again, that's the total energy used per square foot on a yearly basis. To give you a frame of reference, a typical school building at the national average is about an EUI of about 80. So we're talking about a huge reduction in the amount of energy used, and that's cumulative over the lifespan of the building. So every year that delta gets greater and greater and greater against a conventional building of the same type. And it's all about creating these interior spaces. This is a rendering from the design phase of the project of the all school meeting that allow for that congregation, allow for that community. Obviously, we can't have all these people close together right now, but hopefully we're coming out of that phase of the pandemic. And then you get these activated spaces that really can become these armatures that help heat the building. We also contended with a lot of difficult site sustainability issues on this project. The Conservation Commission in Beverly is no easy feat to get through, and this site was incredibly tight with a lot of constraints that we had to manage. And this is an early diagram about all the impacts that the building had to kind of twist and contort around. So we had multiple stream setbacks, along with some firefighting access issues and just access in general because of where the site was located within the campus. So very challenging. We're excited to be able to navigate that and provide a sustainable solution for that as well, which included a roof that is actually meant to retain water. So a blue roof on the lower portion of the building, which is exciting part of the project too. And then we're also starting to gauge at the firm level about what this means for material allocation, material usage. So if we know that we're building these buildings, it's going to reduce the amount of operational energy in the building by increasing insulation levels and making a super tight building and all these things, and even having that extra pane of glass. All of a sudden, we've increased the mass of our building. So this is really technical, but we're putting more material in the building to allow us to reduce the operational energy. So you have to be really sensitive about what those materials are, because the other side is that 20% from that early chart that I showed of building materials representing global warming potential and their extraction from the earth. So part of our expanding focus over the last 3 years is to start modeling all our buildings for total carbon. So not just the operational energy, but all the carbon used to construct the building. And we do that through software in our drafting software. And what we've learned is that it really does put more onus on those material choices because of the increased mass, and they have to work together. And so we're looking at trying to incorporate certain amounts of wood structure into all of our buildings. Waring is a hybrid structure, so there's some steel and some wood. But the great thing about building in wood is that that tree soaks up carbon dioxide its whole life. If it dies and sits in the forest, it gives that carbon dioxide right back to the atmosphere as it rots, so it's essentially net zero. But if we're able to harvest it sustainably in its sustainable, renewable forests, put it in a building where it can sit static for 50, 100 years, and we've trapped that carbon, it's not released back into the atmosphere. And that, combined with Passive House, is really the ticket to truly carbon positive buildings that are actually reducing the levels of global warming potential in the atmosphere. And that's really the next step that all of us have to take on this journey of sustainable buildings. We do that again through this modeling software, and we've learned that combining these two things together, if we can do both at the same time, we can get a full carbon payback in about 8 years by maximizing that sequestration of carbon along with a Passive House approach. And lastly, I'll just finish up with some cool images that were just taken on site yesterday by our excellent certified Passive House consultant and also photographer, Michael Bailey, who's a staff member of mine. Just some drone shots of the building and some interiors. Again, this is in process. So this is from above. You can kind of see the lower campus, the intermittent stream over here, and the upper campus, and the building kind of sitting within, and the upper volume twisting to connect to the upper campus and become that bridge over to the grade up top. This is kind of from that front entry, a little higher up than the image that Cindy showed earlier. This is from the upper campus, again, still a construction site, but the idea and the desire from the school is that from the upper campus, it should still look small and not like a giant building, even though it was this 2-story building. And I think probably I don't know how big the Forum is, but close to the biggest building on campus. But from the upside, from the upper campus, it's a 1-story building with a small entry porch, which is nice and keeps it feeling smaller. Some quick interior shots. Again, these are rough because it's in construction still. The entry area, a couple shots of the Grand Salle with all the cubbies for the students and the stair leading to the upstairs. The stair drops you off right in this upstairs corridor, and you can see the lots of big windows at the end of hallways here. And I know Nat wants one in his mountain house at some point. And then lastly, just the room that we're super happy about, and this is the rendering you saw earlier from the design phase of the project, but the new all-school meeting for the school, which is here to accommodate 100, 180 people when we have all school meeting, but also intimate classes within the kind of conversation pit down here, and really become this beacon, this big curtain wall looking out to the street, to Stanley Street, the front entry, that really does become this kind of new beacon for the school as you enter the campus. So it's really been exciting to share this with you. And I'm going to turn it back over to Cindy, because I know there's some other people that are going to say a few words about this project as well.
All righty, thank you so much, Tim. So, that kind of answered our question about, why Tim Locke and Opal have chose Passive House standards and what some of the features are of the Waring building. One of the things that I thought that I would answer, but with Tim Backlund on the call, I might ask him to unmute here too, and feel free to chime in. is, why Waring chose Passive House. So as part of the building committee, I can say that, we looked at a lot of the different standards that Tim just walked us through. So from LEED to net zero, living building challenge, and some of the others. And we ultimately came to the feeling that Passive House was the right for us, because we felt that while all of the other ones are very good, and I would never say anything, wrong with any of them, Passive House was the kind of starting point from the perspective of, first do no evil, if you will, right? So reducing the energy use that you were going to need to have first and foremost seemed to us the primary goal. And many of the other systems seem to have ways that you could trade out, if you will. You could get more points in one arena if you did less things in another arena. And we didn't like we didn't like the idea of doing that. We wanted to make sure that we started with the best building we could get, the most energy efficient building we could get, and also still continue to look at all of those other things as well. But Tim, do you want to say anything about why the school, was looking for Passive House as well, and why we
Sure.
went through this project?
Just a couple of things. First of all, we had a member of our buildings and grounds team, Oliver Klein, who had some experience and was able to kind of walk us through some of the boons of Passive House. But I think it's once we really got to know Opal, in particular Tim Locke, and you heard his presentation, it's just amazing. They did a feasibility study for us, and we thought that this was the way to go on our campus in that really complicated site that Tim walked you through. And once we started working with Tim Locke and others from Opal, it became more than clear that this was the way to go. And we had in Opal architects who were proven and had certified projects in our region. We really loved their aesthetic and how it goes along so nicely with our campus and with the Passive House model. We couldn't be happier.
Yeah, and the other thing I would add to it, just, for folks, is when I first heard Passive House, I think what often happens is people think of the 70s kind of passive solar, and that's all they know. And so they think it's just kind of building orientation, perhaps, and they don't necessarily, and, maybe they know enough to think about, large concrete structures or something that's going to hold heat, and some windows to provide that. But that's, Passive House standards a little bit more than that. It does include some of those things, right, as we heard, but it's really that super insulated and well-sealed building as well. And I think the other thing that we encountered as we learned through the process is that there was a lot of feeling of, well, they have to be blocky, and they don't, and that they have to have very minimal windows. That was one of the other things that we really encountered. And I think one of the big kind of lightning bolt moments for the committee was when Tim Locke and folks explained to us that, well, actually, you're going to have a lot of heat gain just from all those students in that building. So we actually might need more windows than you think to attenuate the heat you're going to gain inside the building. You're allowed to have some windows. It's okay. But that was one of the things that I think we really encountered as we move forward. And I think a lot of folks will have that misconception. So I want to share that with everyone. So I will then turn it over to Nat Coughlin, our contractor, to talk a little bit about, what was new or same about construction, lessons learned, etc.
Great, thanks, Cindy. Hello, everyone. It's nice to see everybody online here. I think for context, LD Russo, we've been in business for a long time, working for a long time, but this was our first Passive House building. And it's been really interesting to see how I think the concept has really attracted a lot of interest. I mean, we started this building a year ago, and I was Passive House certified as a builder, and we've gotten our staff involved. But now, a year later, we've actually had a lot of projects reaching out to us asking about Passive House, and there's affordable housing, which we do a lot of work in, has really embraced this concept. So it's pretty exciting to see it gaining traction. And I do think what Tim spoke to of sort of the clarity of the output, the idea that there are some very simple standards and it's not about keeping a paper trail for where your products come from or how far they came over the road. It's really about saying at the end of the day, have we built a really contemporary sort of green, sustainable product? And so I think that clarity of concept really resonates. And one of the things I think is worth mentioning is that as working as a contractor, and we're the general contractors and we have all of our subs, I've been really impressed and pleased that it hasn't been as much of a lift or a challenge or a sea change as I think one might be concerned about. And I think part of that credit goes to the fact that Massachusetts has sort of had stretch energy code, and just that the industry in general has really been moving in, I think, good directions. But concepts like building a space that has very low leakage and air exchange, that's a concept that people have been working on for a long time. And so it wasn't a surprise to our trades when we came and started talking about this. It's just that Passive House really takes that and takes a lot of the standards and just steps them up to a higher level. But we always have been trying, we've been doing blower door tests for years, but so our subs were actually not having to learn from zero. We really benefited, and I'd be the first to say that, I'm the face here speaking about it, but our superintendent in the field, our project manager, and then we have countless subs, they've all been really able to sort of listen and learn and see what the added steps were that were required. But, so I think there's a lot of communication required. If you're looking at doing a building with a builder who hasn't done it before, it's just a tremendous amount of sort of talking and learning to keep it from being overwhelming. But I really do think it's taking a lot of things that people in the industry know and just taking them to sort of a higher quality level. It's really a quality control action in a lot of ways. And the caliber of the architect's design makes that much easier. Certainly, if you were to just say to someone who's in the building industry, here, take this house that I designed, but make it Passive House, you're sort of putting, like, you're behind the 8 ball. You've got to really design the structure and the details with Passive House in mind. I think Tim sort of made a comment about the windows. It is true that, like, getting windows and curtain wall systems from Germany brings some challenges, and certainly the sort of the glass and the fenestration and the doors are more expensive than what you would have in a contemporary house. But I've been really struck by how, even just in the last year and a half, we're bidding on Passive House projects now and finding there are just more and more companies moving into that space. And I think you will see more domestic manufacturers and domestic vendors, and that I think will help bring some of the cost margins on some of those key pieces down, as it becomes more well-known and less of a stretch with only a few players in it. But other than that, I mean, I've got to say it's been a really exciting process to be part of. We're really gratified to have been able to do this. Opal's been amazing at teaching us. We're really grateful to have had the chance, and we're really excited because actually we're going to be building affordable housing in Salem for North Shore CDC starting fairly soon, which is also going to be Passive House construction. So the change is happening, and I think there's a lot of enthusiasm, and we happen to have sort of found ourselves at the pointy end of the stick on this. But I think a lot of contractors are going to be moving to the space and learning over the next few years as the concept spreads. And certainly at some point, if people have questions, we'll do our best to answer them. And that's all I got.
Thanks, Matt.
Thanks, Cindy.
So Craig Douglas was our owner's rep, and I guess I wanted to just be able to give him a chance to ask, answer questions about, at least, what was hardest to resolve to hit our budget constraints. We didn't have a huge budget, and so we had to just make sure that we met that, and what maybe some of the cost differences are to highlight between what people think of as regular construction and Passive House, if there were any.
Hi, everybody. Thank you, Cindy, for the invitation. So I'm an architect as well, and my role in this, which I did as a volunteer, was to operate as the owner's rep for Waring, which is really kind of the client face to our team, which ultimately was Tim Locke from Opal and Nat Coughlin from LD Russo. And, what I would say about this, I would say a couple of things. Number one, it comes down to personnel. Like the team that we had between LD Russo and Opal is the best that I've worked with in 28 years of practicing architecture. And that allows us as a team to handle the various challenges that come up with every project, not just Passive House. So that's an important thing to understand. I think the other thing that's very important for me, I'm going to steal from the last question for Nat, lessons learned. What I learned is that you can do a Passive House building on budget, and then it will perform 8 times better than code. And that's what we've done at Waring. And what the lesson that I took out of that is that now that I understand that, because I had no Passive House experience when I took the role of owner's rep, is that to me, it was an ethical component that had to be answered, for me moving forward. So what I've decided is that I can either continue to practice architecture the way that I have, or I can pivot and work in the owner's rep area as a volunteer with firms like Opal and contractors like LD Russo to deliver highly sustainable buildings, Passive House buildings for schools. And to me, that was a really easy choice, because it allows me to essentially leverage my expertise and my experience and be able to do something that I'm not trained to do. So, and I'm never going to be able to do it as well as Opal does. So that's where I would just start at the beginning. The hardest thing to resolve to hit the budget constraints. Well, it's, that's really the same with every project. The goal of the owner's rep at the beginning is to define the project in terms of program and scope as clearly and as cleanly as possible, and then to hand it off to the experts. So we do I did an order of magnitude based on having the program vetted with the school. Then we had Opal do a feasibility study where they had a third-party estimator. That third-party estimator, that information is then used to vet my order of magnitude. And then as we move through design, then we send it out to bid. And LD Russo was the low bidder, and also, in my opinion, the best contractor who bid. And so their bid becomes the third crack at the apple in terms of figuring out what is the value of the work. And then at that point, we hired LD Russo, and we immediately sat down, me, Tim, and Nat in my dining room. We said, okay, now we got to start the value engineering phase. And so over the next month, between Nat and his subcontractors and his vendors, and Tim Locke and his consultants, they put their heads together and they said, all right, how do we build a more efficient widget? How do we make this? How do we get this down to budget? And we cut out 10% of the value of the work through that exercise. So then at that point, we knew we could start. That's how you hit a budget. That's how you control it. That's the same for any project, no matter what. It's always hard work, and you need smart people to work in an open-minded way to deliver that process. And that has been great. Things where it costs different. Certainly the windows are more expensive. You're certainly spending more money on insulation because there's a whole lot more of it, but you're also spending less on the HVAC. And of course, the way the budgets work is that you have one for every job, and that's at the top. And then you have all these line items that you have to fulfill in order to deliver your project. And the money basically flows like water in and out of those, and you make sure that that bottom number works out. And that's what we did. And it's really been, I have to say, it's been challenging, but it's really been a fun project. It's really been a good time. So I hope that answers the question.
Do you know approximately what we came in with at cost per square foot?
I can check that. Yeah, let me pull that up.
I'm just thinking people might be interested.
Sure. I mean, the target when we were doing this originally, which was just a cost per square foot number that we kind of applied to it, was $280 a square foot. The challenge with cost per square foot numbers, of course, is that no project is the same. So you can't, if everything was a project built in a flat field on dirt, that will be one thing. This particular project, as Tim mentioned, had water, it had ledge, it had a high water table. So
It had unknown
me-
utilities, where they were.
yes, yes, exactly. There was a lot to it. You know what, Cindy? Why don't we give me a minute and I'll come back with that question.
Yeah, that's
with that
fine.
answer.
And then if Colin is out there, I was going to ask Colin to speak.
I'm here.
Okay. So Colin, just from the student perspective, we were hoping that you would fill us in a little bit on, you know, what you see about the project, what's been of interest to you, or how you might look at buildings differently.
Yeah, so I think, first of all, I have kind of a unique perspective on this because as a student, I'm on Waring's robotics team, and part of that is we do a project, and last year our project was actually on Passive House, and kind of leveraging the fact that we had a Passive House being built on campus, that we could, you know, we talked with Opal about all that. I'm coming at this with the perspective of kind of knowing a little bit more about this project than most of the students at the school. But I think definitely, I mean, first of all, it's just exciting to have a new building on campus. We have kind of been like reaching our limit, so it's nice to have a nice new building, but it's also really cool to think. I personally just find it really interesting of thinking about a building that is very comfortable and warm and ventilated, but that also does not require a lot of energy. That, I mean, that seems so basic of, it is a passive house, but just that very idea that a house or that a building can be designed in such a way that it does not require energy to keep it in a comfortable state is really cool. And also the idea that we will have a building on campus that is very you know, warm and well ventilated. Right now, at least my pod has been in a room where we've had to keep some of the windows open occasionally for proper COVID ventilation, and it has gotten very cold on certain days. And yeah, I'm trying to think of. I think it's definitely kind of like changed, you know, how you look at a building of not just, you know, not just like what are the architectural concerns in terms of how do we have to build this, what features do we have to include just in a physical area, but also thinking about how well sealed is it, and things like, you know, angles of sunlight and everything that goes into really like optimizing a building without really sacrificing much, and in fact gaining quite a lot in terms of features that you know see from a non-environmental perspective as well, in terms of comfort in the building and just, you know, what it's like architecturally, what it's like usability wise. And I had something I was going to say and then I forgot it.
Do you want to mention anything about the project that you guys did work on?
Yeah, right. That's exactly what I was going to mention. Embodied carbon, and Tim talked a fair bit about this, but what we did specifically for our project was embodied carbon, and the idea that materials like wood are actually very good to use in buildings because they trap carbon and keep it there for a while, which is something that I think a lot of people, you know, don't really think about when it comes to sustainability and when it comes to dealing with carbon emissions. And that's because we did that project and we talked to a lot of the school about that. I think that's definitely something I've thought more about, because Waring is a very you know, we're a school that really wants to do sustainability well and wants to reduce our carbon emissions, but I think a lot of us really didn't know that there was this whole issue of embodied carbon that accounts for so much emissions or possible emissions that could have been trapped. That was a really, really interesting aspect to explore as much as we did.
Great. Thank you.
So Cindy, I have your answers now.
Okay.
So the building, originally we were aiming for 12,000 square feet over 2 floors, and our target number for that was $280 per square foot for construction. We also had a whole slew of line items that we were we were keeping on our side to unknowns around the complexities of the site and other things that Waring had to do in order to be able to occupy the building and get it up and running. The building that we have now is 12,710 square feet, and that came in at $320 per square foot, you know, and kind of the way I track it, which is an overall square footage to the outside face of the building, and then cost per square foot from there. But the more important number to recognize is that the budget that we had at the beginning is the same budget that we had at the end. And we're on budget with all of the program that we established in the beginning that Waring needed. So those two numbers are the ones that really matter, you know, and there's some fluctuation with cost per square foot numbers. You can certainly use them as a rule of thumb. I use them all the time as a rule of thumb. I'm working on a new project, and we're carrying $250 a square foot in that particular case based on that situation and what that building is. But you know, that's kind of where they end. But yeah, so that's the answer, I guess.
Great, thank you. So I know we've gotten some questions in the chat, and I know that Tim Locke has answered many of them as we've been going, but for just to share them perhaps with the rest of the folks, or should we just open it up for people to ask questions? What's the easiest way to go here? One of the questions we have that I don't know if it's been answered was this a Chapter 149 project? And if so, was the coordination difficult between subs?
I could speak to that. So this is not a Chapter 149 project. That's your public bidding process. In Massachusetts, we do a lot of Chapter 149 work. And as far as I'm aware, there haven't been any passive house projects that have gone through that. But I actually wouldn't be surprised to see passive house making its way into Chapter 149. I think it's really about the architects and the owners deciding that that's the direction they want to go in. You know, I think that certainly I think the skill and the capability of the contractors is equally there on both the Chapter 149 side and the private side. But I just don't think it's made its way into that municipal marketplace yet. It'll probably happen with universities and schools first, I would think, before it gets to police stations and libraries and that kind of stuff.
Yeah, and just for any of the folks that aren't familiar, so Waring is a private school here in Beverly for grades 6 through 12. So that's why it wouldn't have had to go through the project, Chapter 149.
Great. Can I just add one piece to that? Just to say, I'm Laura Bittler from Waring. I would just add that the way Waring funded that was fully through philanthropy. So we did a capital campaign for $6 million, and $5 million of that was for this building, and $1 million of that was for student and faculty support. So it was fully funded through philanthropy.
Thank you, Laura. One of the next questions was, which sustainable forest program did you choose to use for wood sources?
So I'll speak to that first. We actually in the Northeast don't necessarily advocate for using FSC strictly for a variety of reasons, but we do try to maintain local provenance and know where the mill is sourcing their wood. And that's largely because the bulk of the wood that's produced in the Northeast is from privately held woodlots. We're particularly sensitive to that up in Maine because 85% of our state is forest, and we also have the highest percentage of sustainably harvested forest in the US, yet we have a very, very low percentage of FSC certified woodlots. And we're trying to do work to change that, not just in Maine, but throughout the Northeast, because it helps us align with other sustainability standards. But the reality is that we have, generations of foresters who have been doing this sustainably, for hundreds of years, and we don't want to necessarily avoid using them because they're not FSC certified, because the sustainability of that economy, at least to us at Opal, is more important in the way we write our specs than that the lumber has that tag on it. If we'd gone to LEED, that would be a different story. And it's a part of the reason why we sometimes advocate for things like passive house over LEED when we're asked to, because of those types of administration issues that don't necessarily recognize regional economic conditions. We hope that we get back to an era in New England where there is more FSC lumber available, but that's local, that isn't trucked from the Pacific Northwest, but that's not the case right now. And so that's a long-winded way of answering the question that it isn't FSC certified, but it was a big point of discussion around Craig's dining room table, for sure.
There were a lot of questions about the HVAC regarding either COVID or the types. And I know you answered a lot of these in the chat, Tim, but maybe you could talk to it again.
I'll just be really brief and high level on it, because I think I did send a few direct messages and also some answers. But the system, you saw some of it on the roof, is a variable refrigerant flow heat pump system. So there's a condenser on the roof that's centralized and serves all of the individual heat pumps in the building, some of which are the kind of mini split looking ones that you saw in the all school meeting, and some are ducted fan coil units inside the building. It depends on the space and what was available for plenum space, but they're all refrigerant lines going back to that same condenser. The nice thing about a kind of like small commercial building scale version of that is that we can heat and cool at the same time, depending on what area of the building is hot and cool, unlike a mini split you might see in your house, which can only heat or cool, not simultaneous. And that's coupled with an energy recovery ventilation unit, which is passive house certified, and it's that specific model so that it's bringing in 100% outside air. So when I have old clients that come to me during the last 12 months and say, yeah, you designed us this great building, but is it COVID compliant? I said, yeah, because passive house requires 100% outside air already. So you're already COVID proof. You can even put MERV 13 filters on it. And in addition to that, you recover 90% of that outgoing energy and heat and use it to temper the incoming fresh air. So you're not blowing 20-degree air into the space on a night like tonight. And those two things work together. That ERV allows us to get some passive cooling in hot months and some passive heating in warm months by preheating that or pre-cooling that incoming air. They're all function through occupancy sensors that sense CO2, or temperature sensors, and they're automated. So it's a very, very small building management system in this building. I wouldn't even necessarily call it that, but some amount of controls that allow us to ensure that we're not getting spiking CO2 levels, but that those CO2 levels are controlling the units and allowing them to modulate up and down depending on the amount of people in the building.
Thank you. One of the other questions we had is, what did you use for insulations, and what did you get out of the windows that you could not have gotten from the first level American windows?
Nat, you want to share that one with me?
I could speak a little about that. Yeah, no, absolutely. So on the insulation, this design had a lot of blown cellulose insulation. It was sort of a primary insulation within the wood framing and within the roof truss system. Actually, I think we're over an R100 in our roof systems, which is pretty amazing. One of the other things that we used on this that is increasingly common, but sort of supersized, I think, with the passive house design, is a continuous layer of thermal insulation outside of the building sheathing. And so in this case, we had 6 inches, is it 6 or 8? I think it's 6 inches on this one of continuous insulation on the outside of the building. And it is interesting, where I'd be curious to see as passive house develops is, and I think Opal's worked on this too, is the idea of how can we find alternate products. So instead of using essentially a fossil fuel based insulation product on the outsides of the buildings, I think there will probably be development over the years to try and offset even that need. But we sort of super insulated the building with this continuous layer of insulation on the outside. And the window question, we happen to get this system from Germany, and I think that I think European passive house window design is much more incorporated into the European marketplace. And so there's some big players there. These, if you walk into the Waring School, you also see these are beautiful windows. It's not purely just a performance thing. I think the company that we used for this, Opal, had a really clear idea of what they were trying to achieve. And these windows are pretty remarkable. But as I said, we're bidding on a lot of projects now where we're seeing American windows that are now designed to meet the requirements of passive house. And it's really about technical standards passive house is trying to meet that American code didn't generally require before. So I think the American marketplace is just catching up to a new standard, and in a matter of years, I'm sure there will be anything you need, there will be options from, I mean, we're in a globalized marketplace, so windows will probably come from all around the world to meet the standard.
Yeah, and I'll just add a little bit on the window front and a little bit on the insulation. So first on the insulation, it goes to that carbon question, right? Like the benefit and the flexibility in insulation lies in that it has very low mass. So it doesn't move the carbon needle as far as resource extraction on a material level as much as we might think. But the cellulose is a great product because it's it's renewable resource and carbon sequestering. We have a sister company called GoLab, which is working on developing a main factory to make insulation out of wood chips, which would replace rigid foam insulation in this type of construction. That's also a product that's already available in Europe, but we priced it on this job as an alternate, but is fairly expensive still to source here, because imagine sending a shipping container mainly filled with air across the ocean. It's not maybe the most affordable thing you can do. It's still not really the thing that pushes a lever one way or the other as far as that mass question. Much more important to get sequestration in low carbon and high mass materials, like the structure of the building. So we still want to prioritize that first and meet the operational energy goals. As far as the windows, the big key in the European market is climate specificity. The European glass market allows you to pick exactly how much solar heat you want to come through the glass and get triple pane, because it's the standard in Europe. It actually costs more to get double pane windows from a German manufacturer than triple pane windows. It's not at all the case here yet. If we go and ask Conair or another commercial window manufacturer, curtain wall manufacturer for triple pane, there's an immediate upcharge. We ask that from Germany, it's the same price, if not less than the double pane. And to add that to the ability to kind of have this thing that's purpose built to the climate. So we have this luxury in New England of having sunny, largely sunny winters. We can capture a lot of that energy. We want to have that solar heat gain coefficient be as high as possible, whereas most domestic windows in the US are still designed for Virginia, like that belt across the country, where the imperative is to reject heat, to keep it out of the building, to keep your cooling load down. And those windows are not appropriate for this climate, they just aren't. And they got that already in Europe as an option. And so it's easier, it's much easier. And they're also fairly comparable in cost still. We hope that there's domestic options that come on board that allow us to be cost competitive here and allow us that same amount of specificity to climate. It's just not the case yet. We use the brand Unilux on this project. I think somebody in the chat had asked if it was Schuco. We have done projects with Schuco that does have distribution in the US as well, but the reason we like Unilux is because it offers both a curtain wall and a window, all with wood construction instead of aluminum. And again, that gets back to that resource question. We've also learned through all of our analysis of extraction and global warming potential through building materials and transportation that the transportation impact on a material is almost nothing. It's about 1% to 2% of the total global warming potential in a material. So contrary to popular belief that came out of LEED in the mid-90s, and used to get a lot of points for locality of material in a LEED project, the reality of the data is that that's just not true. It's really not. And it's not that we don't want to support local economies if we can. If we can get a local product that is comparable and still allows us the same amount of carbon reduction in operations, that's great. But if they're really different, like a window, and the one thing is going to leverage much more potential for positive global warming potential, then we want to use that, because the impact on that transportation side is minuscule. And in fact, if you look at it across the entire lifespan of a material, you actually can't see the bar in the bar chart in transportation. So that's a myth that we've been trying to help bust. Maybe you guys can help on hearing this, but we do hope that there are more local manufacturers soon, to Nat's point, but it's not there yet.
Cindy, I just wanted to add that I've added to the chat, if anyone's interested in seeing the building while it was still going up and the bones of the building inside, and people asked about insulation, Craig Douglas did a great walkthrough and talked about some of the particulars. It's about 20 minutes and there's a link in there. And so you see the building before all the walls are up, exterior and interior.
Great, thank you.
So one other thing that I'd like to add, Cindy, is that, we were talking about budget before, and we're talking about money. The other thing that I learned from going through the Passive House experience with Opal is that there's ultimately an energy budget as well. And it's only being brought to the surface now. That's what Opal is, is a leader at. So that's the other budget that hopefully we'll hit on this when we get our certification. So, but yeah, just food for thought.
Yeah. I think the last two questions I have here are, there's questions about whether we considered a green roof and or if we're going to add solar. And then there's also a question about if thermal mass is something that needs to be considered for Passive House as well.
Which order do we want to go in?
Whatever you want.
I'll talk about the thermal mass real fast, and then maybe Craig wants to talk about other parts because they weren't part of the project. But the thermal mass is a really good question. Yeah, there is Passive House criteria on thermal mass. It's not a requirement to meet Passive House because, again, you really only need to hit those 3 metrics and prove that you did it. But if you can use thermal mass, it will help you for sure. So by thermal mass, for those that don't know, we mean the ability for high mass materials such as concrete to absorb energy. That could be cool air, that could be warm air, that could be, it could even be energy that's emitted radiantly, like the sun's energy, soaked up in a material that gets slowly released over time. That definitely does help meet that heating load and energy load criteria and keeping it low. The issue, of course, is that concrete is also a very, very high embodied carbon material. So that's kind of like definitely a crux point right now between Passive House and total carbon, is like, how much concrete do you really want to use? And initially in the early Passive Houses in Europe, if you go tour them, which when we go over to Passive House Institute conference, we get to go on these tours of these Passive Houses that have been in operation for 20 years. They're all concrete. They're concrete with a ton of insulation on the outside of the building. Concrete floors, concrete columns, everything. And there is a cheaper economy for concrete there, but we're also learning that there's a really, really high life cycle cost to using concrete. In fact, there's islands in the South Pacific that are disappearing solely because of sand extraction to make concrete. So that's definitely like the next step in synergy between Passive House and embodied carbon to deal with. Because if we can't use thermal mass in that way, then we have to be careful about our envelope even more to make sure it retains heat. But there is a concrete slab on the first floor of this building, a little bit of one on the second floor. But largely the structure of this building is steel and wood, which are not considered thermal mass sinks in this in the way Passive House assesses it.
So the question about the roof, one of the major impacts that we had to mitigate through this process was the fact that the building is so close to an intermittent stream. So we had wetlands issues that we had to deal with as well. So there's basically strict drainage requirements that were part of the order of conditions from the Beverly Conservation Commission. And so we've mitigated that in a few different ways, but if we just limit it to the roof right now, the blue roof, which is the lower one, which is also where you can see the HVAC equipment on the roof. The intention of it is that the water drains off the roof at a much slower rate than normal. And what it does is the roof will hold the water and it controls the amount of water as it releases into the site so as not to overwhelm, flood the wetlands and drain out the plants. There's other issues that we have, we've used permeable pavers, which allows water to go through there and seep into the ground rather than just run straight off into the wetlands. So those are kind of the impacts that led us to a blue roof in this particular case. Again, very complex site. The other piece in terms of the solar panels, the particular location of this building with all the trees on the south side essentially prohibit being able to put solar panels on the roof because they don't get enough sunlight. They're all in shade from the trees. I know that, and Cindy, feel free to jump in here too, but we have discussed about, in terms of bringing in solar panels, where else we could do it on campus, as part of the larger kind of green sustainability goals of Waring and, doing projects moving forward.
Yep, sounds perfect. So I think we've answered all the questions, and we're certainly, we're actually a little bit beyond time, but we did have, I think, one more slide here to talk about for the rest of to finish out. So let me see if I can get that to move forward. So we just wanted to give folks an idea of, some building code, zoning, and ordinances activity that's going on as well, because there's several of those things that impact not only, what we've done here at Waring, but what buildings will look like in the future, right? So the Mass Climate Bill, as many folks are pretty familiar with that, has kind of gone back and forth, passed through the House and the Senate, went to the governor, and the governor has given it back to the legislature to review with some comments that he'd like to see some changes. But that does include, along with kind of the roadmap to getting to lower emissions, it specifically includes some building ordinance requirements or building code requirements. So it's looking to allow for the next lower building code requirements to be adopted by the state level so that then cities can adopt them independently. And that also is looking at some net zero codes as well. The Salem Green Building Ordinance, Jeff Cohen, are you still here? You are. Do you want to talk to that real quickly?
Sure, and it's unfortunate that I have to follow Craig and that, and Tim, Colin, of course. Really impressive presentation, and wish we could do something like that for the whole city of Salem. So we started at a very low baseline, underwater really. As much as Salem is a green community, in the sense that we're the fourth community to do municipal aggregation. We bought all our streetlights, turned them to LED. We have perhaps the most innovative solar project on a municipal building, north-south panels that has produced will produce $1 million of revenue over 10 years for the schools. We've been a solarized community twice. In spite of that, 40+% of the greenhouse emissions come from buildings in Salem, and could be more. And I'm personally ashamed that we've been doing lots of development without any resiliency, without any minimum building standards. We have a fairly new community life center, which is below sea level, has really no resiliency at all, and would have cost pennies on the dollar to implement many things at a much lower level than this passive house. And so now to retrofit that building will be extraordinarily expensive. So we decided a couple of years ago to write a green building ordinance. And it's at the city council at this point, the Public Health, Safety and Environment Subcommittee. At some point, there'll be a public hearing, and anyone on this call or anyone you know is welcome to testify. Many people on this call helped with the ordinance. There's really just a couple of key components. We chose LEED Silver as our base. For some buildings a certain size, we would mandate LEED Gold. For municipal properties, we would have a lot of extra criteria, permeable paving and other things, and a green or solar roof, knowing that the nature of shading, we, pretty condensed city, solar roof is not really viable in many properties, and to have a green roof. So encourage everyone to come to the council meeting if they can. But I just wanted to say again, just a totally impressive presentation. Thank you.
Thanks, Jeff. And then just, oh, Pat, go ahead.
I just wanted to say, in relationship to what Jeff just presented, that SAFE is 100% behind this, and give a shout out to the Rocky Mountain Institute, where a number of us who are members of SAFE and members of the Sustainability, Energy and Resilience Committee participated in the Rocky Mountain Institute Building Electrification Accelerator. And that really has educated a lot of us. So if you're new to all this and you're on this call, and it does seem a little overwhelming, I have to say a lot of us on this call have been through 8 months of talking about this stuff, and there's still stuff that's new that's coming up, but we want to push forward. And the net zero building code that is in the roadmap bill that is currently back in the legislature. And I know Representative Paul Tucker is on this call, and we are really hoping that, and Paul has said this a number of times, that we will get that roadmap bill passed again in the legislature, and that if the governor overrides it, that the legislature again will take the move of passing it. It's really important. We feel it's really important to offer municipalities the option of net zero as part of the building code. It's not that every community has to do it, but it's that if communities opt to do it, they can do it. Thank you.
Great, thank you. Yeah, and as Pat mentioned, as part of that Rocky Mountain Institute Building Electrification Accelerator, we've gotten a chance over the past several months to talk with many communities, Brookline, Arlington, Cambridge, and many others that are, moving forward with different, citywide specific ordinances or zoning or codes. And this chart here just shows a couple of those, as well as, so there's, 12 plus cities and towns here in Massachusetts, Denver, Colorado, and other cities around the country are looking at prohibiting new fossil fuel infrastructure. Boston's mandating an assessment of all electric solutions so that at least, new buildings are being considered to be all electric first and foremost. If they can't be, then they have to kind of prove why not. And Seattle is got local codes to incentivize electric buildings as well. And that's one of the things to note here on the Waring building too that we didn't mention, but the previous building that was on the site that we replaced with this new building was heated with oil, and the oil tank was within the wetlands area of the stream besides, right? So that's a huge environmental benefit in and of itself that we got to remove that and take that out of the hazard zone. So that's kind of another thing to consider. And then certainly with the new administration, there's a lot being moved forward on climate legislation. And so we may see more from a building perspective there as well. So with that, I would like to thank all of the attendees and all of our panel I don't know if the panel, anybody on the panel wants to speak up about the idea of some of these codes, but I'll give you that opportunity before we close out as to what you think about the idea of some of these codes coming through.
Go, Tim.
The more stringent, the better, but also as far as energy use. But generally, I think that's good to see. I mean, we finally just approved, I know you guys have had it for years, stretch code up here in Maine, and we're of course designing far beyond that. But I think the big thing we'd love to see, ultimately down the road is codes become outcome based, like passive houses, versus prescriptive, the way our codes in the US are currently written. That's a much bigger ship to kind of turn. But the beauty of outcome-based codes is that it's about not the path you take to get there, but that you do the right thing ultimately, and that the building performs in a way that will help the climate down the road. And I think as architects and advocates for that, certainly myself and most of the colleagues that I know and work with would love to see that as the ultimate goal for codes, to get to something that's more like that. And I think it would help builders too, honestly, because it would put less limits on the way things are done and more goal oriented about how the building ultimately functions. That's all I'll say about that.
I would certainly say I think the way Massachusetts has embraced more sort of energy efficient codes over the years has really moved the needle in just the standard construction out there. And I also think that, and this is somewhat sort of just a personal opinion as well, but I really feel like the real change comes from as the culture changes, and getting people bought into the concepts and buying the ideas. I think that more embrace the embrace of more green building methods and materials and outcomes is also starting to catch on, just as building owners are recognizing there's a lot of value to them and things that matter to them. And that's why I do think you see a lot of people reaching beyond the minimums of codes already. So hopefully that will also continue to happen. I think every community has a different path to changing their codes, and in some places it's easier and in some places it's harder, and some it depends on your population. We also have to be careful about, we have a housing crisis in part because things are really expensive, and I think there's an ebb and flow on cost as well that there's some negative impacts if code drives cost up before the marketplace is really ready for it. So I think it's a super interesting question. I'm glad people advocate for more stringent codes, but I think a side effect of that, even if it doesn't pass, is often that the culture comes along a little bit every time, even if the codes don't necessarily get passed on the first shot.
So, and I would second what Tim and Nat have just said. I think, the codes that's the way to raise the water level, across the board. To me, where my focus has really been is, if you make it part of the culture and you make it part of the core commitment to any project at the beginning, then the code when it comes to energy is ultimately irrelevant. And that's really where I've decided to focus my efforts, because we can do it now. We know how to do it now. And the great thing about Passive House is it's based on science and not bureaucracy. So I think the building industry in general is much, much better in terms of regulation than it was when I started back in the early 90s. So that's good. So, onward and upward.
Great, thank you. I don't want to put you on the spot necessarily, Paul, but I did want to give you an opportunity to talk if you wanted to say anything. Paul Tucker.
Yes, thanks, Cindy. This is fascinating. When I saw the topic for this month, when you posted it a couple of weeks ago, I knew I wanted to make sure I saw it. This is like a whole new world to me, and just the presentation and the way it was done was just fascinating. Pat is also correct that I'm very optimistic that we're going to get our bill through. I just saw one of the headlines came through about an hour ago that the Speaker of the House just reaffirmed his support for getting our bill through. So very optimistic, a lot of good things happening, and a lot of it, we're blessed in Salem to have a lot of great folks that are very committed to this. So thank you for opening up my eyes again, and look forward to more. Very interesting comments at the end too. You know, the balance of you know, the codes. I know that was one of the issues that developers had tried to prevail upon the governor to take those pieces out. I think that the points back and forth, we talk about it, but if we're really going to make a commitment to it, these are some of the hard decisions that we have to do and push forward. So that's how I feel. So thank you. And Cindy, thank you for putting this together. Fascinating. And shout out to Colin. Excellent job. Great having the students' perspective.
Okay. So again, thank you to all that came, and special thanks to our speakers, Timothy Locke, Nat Coughlin, and Craig Douglas, and Colin, who I think has jumped off to finish his homework up. And just to let everybody know, next month's topic is urban agriculture. So we'll talk a little bit about trees and maybe some of Mac Park's food program, etc. And that'll be April 1st. Really not an April Fool's joke. We really will have the meeting at 6:30 as usual. And follow us on safe.org for our website, or Facebook or Twitter. And we appreciate everybody's attendance. Thank you very much. Good night, all.
Thanks, Cindy.